we as a team, Roshan, Himanshu, and myself, today are trying to address the message like how data management will be easy with the SODA multi-cloud. So myself and Roshan from Click to Cloud, basically Click to Cloud, a product company dealing in to provide automated solution for AI ML technology and cloud migration, storage, infrastructure management using AML features and contributing to SODA since 3 years. So today, with this agenda, we proceed here. So first, we want to share how is the idea come up with. So nowadays, in current IT trends, every organization is trying to adapt any type of cloud technology and practices like private cloud, public cloud, hybrid cloud, and on-premise storage. So basic challenge which occurs is to manage the capacity and then how to manage the data. So SODA multi-cloud will provide a solution, end-to-end solutions on this. So let's see how it can be done. Next, please. So as everybody has spoken on SODA, so I just give the gist of SODA. So SODA Foundation is a sub-foundation of Linux, arose in early 2016 as OpenSDS, aiming to address storage integration challenges, also aiming to bring industry leaders together to define a common framework which can basically support AI, ML, IoT devices, uh, focusing for data encryption, data governance, analytics, and to support big data. Next, please. The vision of SODA is to again define a unified storage framework, which will be at the end of open, autonomous, ready, and real. So when I say open, it means there will be no vendor locking, and then intelligence will be integrated with, and automated data service will be provided here. Next, please. Um, with a license and certification ready for vendors, SODA is a ready platform to be used. Also, it is designed for real use cases in the sense that you can deploy it on the cloud native environment and on premises. Next, please. So framework focuses on the area to support mobility, then production, life cycle, storage platforms, heterogeneous storage platform, then governance and orchestration. Next, please. So basically, SODA is driven by TSC community and user community and open source community. So in earlier 2019, it is enhanced and upgraded to SODA from OpenSDS. Next, please. Now coming to understand the ecosystem and projects of SODA. So SODA have a very large number of projects, sub-projects aiming to certain goals. As you can see, SODA dashboard. So it is a UI solution, front-end solution where a different APIs provided by SODA is consumed here. And the end features of SODA can be tested with the help of this dashboard. Then coming to API, basically, so API is basically to integrate all the heterogeneous storage backend and providing a standardized specification and for storage management. Then controller, this is a role player to create a communication between API dashboard, and also it handles the service and API flow. Also maintain the metadata required here. Uh, Next is a dock. So dock is a docking station for all the storage backend support here. Next, please. Plugins on there is a Northbound plugin basically targeting to support cloud native environment, Kubernetes, and related features, and focuses to extend all these industry platform and applications here. Then SODA multi cloud. So this is the main attraction of the agenda today. So multi-cloud basically provides end user with object storage management features, lifecycle management feature, and data migration features with the help of dedicated API and UI dashboard. Then telemetry. So basically, it helps to pull the statistic and health information of the supported storage backend uh, in the form of infra, then orchestration. So this framework, this project will help you to customize the flow and makes easy the execution of the task. Then intelligence is the indirect implementation of telemetry. It also explains the execution of exporter, how it begins the data statistic and how it communicates with Kafka. And certain ML algorithms are also implemented here. Next, please. So this is the pictorial representation of the ecosystem and whatever projects I have highlighted. As you can see, the dashboard, NBP plugin, API controller here, dedicated multi-cloud project. Then you can see the vendor drivers here, common SODA vendor driver, and then the supported vendor drivers here. So this will be discussed in detail with the architecture in the upcoming discussion. So next, please. Now coming to multi-cloud, which solves this data management. So SODA multi-cloud, it's a dedicated project for data management of object storage, block storage, and file storage. And it provides agnostic data management for hybrid cloud, in-cloud, intercloud, and it supports S3 data backend manager, so which enables you to work on heterogeneous storage backends. Supported cloud providers are AWS, Azure, GCP, and many more are there. Then in on-premise storage, it support Ceph backend. Also, it's integrated Ceph backend from Channel Uniform project. Then it provides a policy-based data mobility in public and private cloud. It provides a highlighted feature of object file and block storage. So we are discussing in further slides. Next, please. So coming up to the features first, to see what providers is support in object storage management. We support AWS, Azure, GCP, IBM, Huawei, Alibaba, Cephenic. In block storage, we are supporting AWS EBS. In file storage, we are supporting AWS EFS, Azure, and GCP. Coming to object storage management feature. So this feature leverages end user to do object operations on the supported list of providers, where the main highlighted feature is a large upload. You can upload TBs of data with the help of multi-part upload functionality. Then in migration part, you can try in cloud migration, you can try cloud migration, you can schedule migration. So when I say in cloud, it means in the same provider, you can migrate to the different region. When I say cross cloud, you can say the source will be one of the cloud and destination will be the another. And in the schedule migration, like you have predefined event time for the migration, then you can do that with the help of schedule migration. Next, please. Coming to lifecycle management. So for easy understanding, I would first give an example. So any object have a life cycle starting with a standard storage, taking example of Azure. And then according to consumption, you can control and change the storage class from standard to standard I and Glacier, which indirectly help to restrict or control the consumptions behind this object. So that can be done with this object lifecycle management feature. And this conversion of the storage classes is a transition which is in cloud and cross cloud in SODA multi-cloud. So when I say in cloud, it means the transition will be done in the same provider. And when I say cross cloud, I can say If you're starting with a standard storage of AWS object, you can transit it to a archival of Azure on requirement. So there are certain functionalities supported on object management is encryption to object. So that is SSE based encryption. So which restrict the direct access and download of object. Then there is versioning feature. So you can maintain the different copies of same object and manage it with the help of this feature. Then there is bucket ACL policy. So basically provide access control over the bucket uh, and indirectly it will be applied to objects. Then in block storage, you can easily perform cloud volume operations to the supported provider. Then in file storage, you can perform file share operation on the supported providers. So I hand over to Himanshu for detailed architecture understanding. Thank you.
Yeah, thank you, Archana. So now we will go through the SODA architecture. So I'll reiterate some of the points which Archana mentioned about SODA. So SODA has uh, uh, end-to-end portfolio to provide a common unified data and storage interfaces. So the vision of SODA is to provide store, run any data anywhere. So as Archana mentioned, that it's an umbrella for data framework integration of multiple open source projects to provide overall unified, intelligent, scalable and data management platform. So on the top, you see like different not-bound plugins. So it provides integration with multiple top industry platforms like Kubernetes, VMware, OpenStack, to interface with SODA API by providing different northbound plugins. So like CSI plugin for Kubernetes, OpenStack, and VMware storage management plugin like NGC, VRO, and many more. Now coming back to the heart of SODA, we have projects like API Dock Controller, which forms the heart of SODA. So SODA API provides implementation of SODA API standards for managing like data and storage resources, and the controller wherein is responsible for storage profile management and also storage pool selections and schedulers. On the south side, to provide heterogeneous connectivity to various storage backends. So Dock is acting as a docking station for multiple storage backend drivers, including NetApp, Dell EMC, Fujitsu, HP, Huawei, native drivers, and many more. And also recently we have introduced, I mean, the SODA have introduced infrastructure manager, which is basically a SIM Delphin project, which is storage infrastructure manager provides to provide unified intelligent resource management for various storage backends. So we have support for Dell EMC for now, and also this is also extended for further various storage backends. And also it supports alert management and metrics data collection and performance monitoring basically for different storage resources. So coming back to the main attraction of this talk is about multi-cloud. So SODA multi-cloud, as you can see on the right hand side, we have a multi-cloud project. So which is basically a data management for different hybrid cloud, inter and intra cloud for various cloud vendor support like AWS, Azure, GCP, Huawei, IBM, and many more. So if I deep dig into the multi-cloud architecture. So multi-cloud is basically a distributed, scalable microservices based system with pluggable services. What I mean by pluggable services, like, so the user based upon the storage requirement can plug different services into their cluster to get the benefits of the multi-cloud. So based on like if the user has the only the to manage only the object, they can plug in S3 service. If they have file services, so they can plug in the respective file service. So as you can see, multi-cloud is a layered architecture which has different layers like API, starting from the API layer the service layer, the backend layer, and the data persistent layer for persisting our metadata related to SODA multi-cloud resources. So SODA multi-cloud basically exposes the REST interface to the external world. So one of the consumer, as Archana also mentioned, that SODA dashboard is one of the consumer where you can try out features from SODA multi-cloud. And similarly, we can have multiple other REST clients to interact with the SODA multi-cloud. The service layer basically includes the different controller services like S3 service, file service, block service. I'll go dig deep into the further slides for these services. And the identity services, we use Keystone as a authorization and authentication mechanism for authorizing our API request for multi-cloud. And of course, in the south side, we have different backend layer adapters, which have their like storage type of adapters for doing cloud operations. So like if the AWS EFS, I want to do cloud operations, so the respective driver factory will be responsible to do the operations from that cloud provider. That is the AWS. So let's dig deep into the backend service. So this is one of the services which is provided by SODA multi-cloud. So basically, backend service, all the multi-cloud services supports authentication mechanism using Keystone. So all the APIs are being authenticated using API handler, which is our and which includes the identity manager, which authenticated the API request. And once the requests are authenticated, it been rerouted to the respective managers. Like in case of backend service, it is a backend manager, which checks for the request of any creation, delete, update, or get backend. So basically, backend service is nothing but a placeholder to keep the backend profile registrations, which includes like user cloud profile, AKSK, region, buckets, and all of that. So this is a bookkeeping of the cloud profile. And once the bookkeeping is done, then the respective cloud vendor operations can be done to by passing the calls to the actual backend service. Yeah, so this is one of the important service in multi-cloud, which supports object storage. So this is called as S3 service in multi-cloud. So we support all the S3 compatible APIs, and uh, just like the other services, it also supports the authentication using the identity manager of Keystone. And once the Keystone identified that the user is authenticated as the correct user, then it reroutes the call related to the S3 operations to the S3 controller. So I'll give some thought about like what exactly a bucket in SODA multi-cloud. So a bucket in a SODA multi-cloud is a virtual bucket which is mapped to a physical bucket. There is many to one mapping for this virtual buckets to a actual backend bucket, and location mapper is helping us to find out like which cloud backend the object or the bucket belongs to, the virtual buckets. And it once it get identified, the actual operations on the virtual bucket will be performed based upon the metadata operations. And once the metadata is updated, the respective call get transferred to the backend adapter layer to do the actual object cloud operations on the cloud, like create bucket, delete bucket, or upload or download objects. Yeah, so now if I talk about the use case of migration, so this service plays a important role in that. So data flow service, don't get confused with this diagram. So this is like a combination of different various components like policy manager, connector manager, plan manager, job manager. So each have his own responsibility. The policy manager manages the policies. The connectors, we have like source and the destination connection information. The plan, basically the migration plan, and then those plan can be executed manually or automatically based upon the plan creation. Once this have so we also have a scheduler to schedule all these migration plan jobs. We manage these kind of operations using Apache Kafka, a distributed streaming platform, to pull in and put the jobs into it, and the actual migration has happened using data mover service by pulling the jobs of migration from the Kafka. Similar to objects support, we also support file resources from different cloud vendors like Azure, GCP, and AWS. So similar, the S3 operation, the file get translated to the file service controller to get the actual backend operations, to get like file type, storage type, and the once this is identified, the actual call is translated to the backend adapters to carry out the operation on the cloud backend. Next slide, please. So similar to do the volume operations, we have block service similar to the file one. Next slide. So so this is the pictorial representation of what SODA multi-cloud services. So we have like Docker containers of all this, so pluggable services. So the user can deploy as per their need the services to deploy SODA multi-cloud. Next, over to you, Roshan, to give some thoughts on the use cases of multi-cloud. Thank you.
Yeah, thank you, Himanshu. This is Roshan here. I'm working as a lead developer at Click2Cloud India. So let's till now you have like you got the information about what is SODA project, what is SODA, and how multi-cloud services works. Let's come to its use case of multi-cloud project. So I am going to show you two use cases. First is migration, in which we will migrate from one cloud vendor to another cloud vendor, migrate data from one cloud vendor to another cloud vendor, and the another one will be the lifecycle management. So for bucket or object migration, what we need to do is we'll have to register backend, create buckets that I will do in a demo, which I will show you soon. So in that we will upload objects, and later on we will migrate that data from one cloud to another cloud, and later after getting migrated to destination cloud, user can use that data for another purpose for his use case. So, and I will quickly discuss object lifecycle management in SODA. In SODA, we have generalized storage class like tier 1, tier 99, tier 999, which is mapped like for tier 1 in AWS standard, in Azure hot, in Alibaba standard, in Huawei standard is there. Likewise for tier 99 and tier 999. So in lifecycle management of SODA, we support in-cloud and cross-cloud lifecycle management. So in cloud services, you must have seen in-cloud object lifecycle management. In addition to that, in SODA, we support cross-cloud object lifecycle management. Suppose you have a data, you have an object which is not used for some days. So if you don't want to incur cost on that one, so you will delete it. So for that, we have expiration policy also. So like you can see in here example, we have uploaded object into bucket test, and we have set policies like after 30 days it will go to tier 99, after 60 it will go to tier 999, and after 90 days it will get deleted. So if the object is not in use, so after 30 days it will transfer to tier 99, which is in S3 Amazon, AWS S3, it is standard IA, and it will transfer to Glacier after 60 days. And if it is not in use for 90 days, it will get deleted after 90 days. So I will go to demo thing. So far you have seen, you haven't seen SODA dashboard so far. So this is how SODA looks like. and we are going to add register backend here. To register backend, just we need to click on plus and we'll AWS backend here. So for to add AWS backend, what we will need a region, endpoint, bucket, access key, and secret key. To save time, I have already added one backend of AWS. So so this is the backend and which is connected to physical bucket OpenSGS test AWS. And I have added another two backends for Azure also. So which is connected to like this backend is connected to test bucket and this is with Sora test. So let's go to creating bucket, that is virtual bucket. We'll go to resource manager and to bucket and we'll create one bucket here. So let's create test AWS bucket and we will select type AWS S3, select backend which we have added AWS backend, and we can enable encryption also from here in which SSC is supported. So I will create bucket AWS. So it got created here, and I will create one more bucket of Azure also. Test Azure bucket, and we'll select type as Azure Blob Storage, backend as Azure New Backend, and we'll disable encryption and create one bucket also. Yeah, we got the bucket. Now we will upload some objects in test AWS object. So select one. Quickly upload this one. I will upload one more object of big size, little big size. So Soda supports multi-part upload also. In multi-part, it supports in migration also. It supports multi-part. So the bandwidth will not be an issue while migrating data or while uploading data. So it will take some time as it is multi-part data and of big size. So we have uploaded one object. Let's see on AWS console how it got reflected. So this is the physical bucket that we have registered as a backend in Soda, and we will refresh this one. So here it is test AWS bucket which we have created there on Soda, and this object got uploaded here as 2. I'll wait for another object to get uploaded. It is going to upload. 30% is uploaded. Takes more 20 seconds. Yeah. The object got uploaded here and it will reflect here also. Let's check, refresh it. Yeah. So on AWS, the object got uploaded, and now what we will do, we will migrate this object from AWS bucket that we have created and uploaded object in it to Azure bucket. So for that, game plan from AWS bucket, we are going to migrate data to Azure bucket. We can schedule it, but now right now I will do it immediately. And there is option of do you want to delete object from source after migration? So I'm clicking yes here, and so here migration will start. It will show percentage also how much data is getting migrated. So for like if it is huge data, you will see the migration process progress here. And while I will check, so it will show the migrated object. 1 out of 2 objects got migrated here. So it will take some time to get migrated, and let's check the bucket test Azure bucket. 1 object got migrated, so you can see the 1 object which is got migrated here. Yeah. So as soon as that migration get over, the another object will get reflected here. Yeah. Meanwhile, I will show you how to set lifecycle policy here. Suppose we have this test AWS virtual bucket and we are going to set up lifecycle policy here. So for that, we will create demo lifecycle policy. Prefix you can set, and rules storage transition I will set. By default, the object will be in tier 1, that is standard. We are going to migrate that object to tier 99 after 30 days. If it is not used for 30 days, it will get migrated to, the storage class of that object will get changed to a standard IA of AWS or tier 99. And if you want to perform cross-cloud transition, you will have to select like this is of AWS bucket, and we can select Azure backend here. So what will happen after 30 days? The object will get migrated to Azure backend and in the tier 99, that is fold of Azure. So I will set it again. This is enabled policy, and we'll check the migration status here. Yeah, it got succeed here. So we'll check on bucket which we created in console. Yeah, both the bucket objects are there. Now we'll go to Azure console and we'll check here. So here no objects are there currently. We'll refresh it. Yeah, test Azure bucket is created. There is virtual bucket inside the physical Soda test container, and inside it you can see the two objects which got migrated from AWS. So this is how migration work in Soda. And yeah, that is all for the migration and the demo purpose. Yeah, thank you. If you want to contribute, and join our community, you can ping us on Slack, and all the details are there. You can visit the booth and get the details, more details about the Soda Foundation. Yeah, thank you.
Thank you, Himanshu. Thank you, Roshan. And thank you, Archana, for a wonderful, wonderful talk. I'm sure the audience loved it. Any final thoughts before we part ways for today?
Yeah, so we would like to encourage experts and audience to join us. Like Roshan has mentioned, you can get the details from the booth and also from the sites mentioned here. So yeah, so we would encourage people to join and enhance the Soda Foundation and the project's contribution.